Hello everyone, welcome to STEM Education. I am Nandini and today we are going to learn biology for year 12 AS level. The topic will be chemistry for biologists. Okay, so when we are talking about chemistry for biologists, now biologists, as we already know, biologist, the person who deals with all the things, all the living organisms. Then, what is basically about chemistry? So, chemistry is a science which deals with chemical reactions. So, the question comes, how these two words have combined together and what is the meaning behind it? So, yes, these two words coordinating with each other. Biologists are the other and totally different branch. Okay, but when we talk about chemistry, chemistry is a scenario or a subject which is dealing in everybody's life. It's not like even a small molecule, what you see, even a small atom, even complete of body of yours, from single strand of a hair to the tip of your toe, everything is made up of chemical molecules. And the most important chemical molecule which come in our life is water. Water is also known as elixir of life. Now, why it's called as elixir of life? Basically, it is like required by each and every organism, from a single microscopic organism to a higher level organism, plants and animals, both. Now, water is showing the chemical formula H2O. Here, 2 hydrogen and 1 oxygen are the two elements which are involved. Okay, trying to understand the concept as it is 2 hydrogen, 2 and 1 oxygen. But the number of elements which is involved in this are 2, hydrogen and oxygen. So we can say the ratio becomes 2:1. If we are trying to introduce like H/O, okay? So 2 hydrogen and 1 oxygen. Do remember it, 2 hydrogen and 1 oxygen combining together and then they are forming elements. Now, if we see about chemical molecules, understand what is chemistry of life. Yeah. We already have started with water molecule. Okay, but chemistry of life is very important. If you actually have seen or have heard, we always keep on hearing about the theories and everything which came into an existence, the Big Bang theories, Big Bang hypothesis, the formation of Earth and the core, and everything, like everything, step by step reaction. Where even if you try to notice a single and each reaction, for example, Earth was supposed to be called as ball of fire. Okay, ball of fire, which means heat, again chemistry. Heat is also part of chemistry as well. Okay, but if you say about biology, yes, it's a part of too. Why? Because obviously your body is emitting heat to maintain the temperature, right? So, understanding what is chemistry of life. Now, each and every organism's nearby surrounding is made up of chemical compounds. Okay, so we can understand each and every organism in a surrounding, each and every, even if it is, when we talk about biology, it is only about related living organisms. But when we talk about chemistry or chemistry for life, chemistry for non-living organisms, if we talk about each and every organism in a surrounding is made up of chemical components, which means I'm talking about each and every organism, each and every molecule, each and every atom which is actually near or in the surrounding of yours. Okay? So, here when we come, each and every organism sits from a single cell or microscopic to a multicellular or a higher level organism. Everything is made up of chemicals. Everything is made up of chemicals. So chemistry for life is not only just for life. You can also find them as an inanimate objects like stone, like your benches, like your phones, mobile phones, or you can say your tablets, your laptops, etc. Why I'm giving you this example? Because if you turn around, you can see chemistry everywhere. Okay? So now, if we try to see this chemistry for biologists, उसमें chemistry for okay. So if we try and understand about chemistry, there is presence of different elements in a different form. So this is even including your life, living organisms. Okay. Every single body is made up of some amount of chemical components. For example, if we talk about a cell, which shows presence of cell wall. For example, if we talk about a plant cell shows presence of cell wall, where this cell wall is made up of polysaccharides. And this polysaccharides, they contain carbon, hydrogen, and oxygen. Okay? Whereas when we talk about the next example, an animal cell wall or an animal cell membrane. Now the cell membrane is made up of lipopolysaccharides or lipoproteins. Let's consider lipoproteins. Here are two components, lipids and proteins. Both are being involved, where this protein contains your C, H, O, and N, nitrogen, whereas C, H, O. Now, lipids can have their some compound lipids or derived lipids or anything. So they might be having sulfur, phosphorus, anything present in there. So basically, we can say lipids and proteins. Okay. Here, if we talk about these are the elements which are being placed in a periodic table nowadays, and so that you can actually know about their atomic mass and atomic numbers. Same thing this is when you study about carbohydrates, lipids, and proteins. That's supposed to be called as your organic chemistry. Organic chemistry, whereas when you study about this is about compounds. Whereas when you study about free ions floating inside the body, that's called as your inorganic chemistry. That's called as your inorganic chemistry. So this is chemistry for biologists and chemistry for life. Now, moving to see how the chemistry for life works. Now, when we talk about chemistry for life, we know that atom is considered as the basic element. Atom is supposed to be the structural and functional unit of the elements. And this is the only one which is the smallest element of the complete family. But the point is, without atom, nothing can happen. There is none of the things which is going to form or made if the atom is not present. Okay? So atom is playing a very important role into the structural and functional unit of elements and also the smallest element of the complete family. Okay? So when two atoms or more, okay, when two or more atoms of different element combine together, they form compound. They form a compound. This is what a basic general chemistry says. Okay, when we talk or when we study about chemistry for a life. Okay. So what does an atom is made up of? If we talk about an atom, it's made of a nucleus. Okay, an atom is made of a nucleus. Now, what it exactly is containing? Nucleus contains positive proton and neutral neutron. This is what present inside the nucleus. This is what present inside the nucleus. So we can say nucleus contains positive proton and neutral neutron. Neutral neutron, which means there is no positive or no negative charge. We can say neither positive nor negative charges found. On neutron. Okay, so there is no positive, no negative charge on neutron, whereas when we say proton, there is presence of. Proton will always show presence of. Positive charge. Proton will always have a positive charge with them. There will be no charge present on neutron, but there will be positive charge present on the proton. Okay. Now this was a general instruction. There is one more point, because if there is something positive present within the atom, definitely there might be something which is going to be negative, but they should be present somewhere. Either it may be nearby or it may be surrounding the atom or something like that. Because without positive and negative combining together or the like making the neutralization, there is no point. Okay, fine. Next, we are moving to see what is then present with the negative charge. So the element or thing which is present with the negative charge actually is surrounded by negative charge electron. Atom is surrounded by negative charge electron. So how, if we want to see the diagrammatic representation, how we are going to see them? Okay. So Consider this as an atom showing presence of proton and neutron. We are resembling. Consider this as an atom where there is presence of proton and neutrons. So P is standing for proton and N is standing for the neutron. Now, if you see, there is always an orbit. Always an orbit formed surrounding the atom. Okay, an orbit surrounding the atom. This is in a nucleus where there is presence of proton and neutron. Now, here there will be an orbit formation. And the electrons will be placed accordingly. For example, this is general. Always after the atom, there is an orbit which is formed called as your S shell. So that orbit will be always having tendency or the maximum capacity to hold is 2 electrons, not more than that. And for the next shell, there will be always more, like 8 electrons. So I have made this 2 in the first and the 8 in the next. So if we talk about H2O molecule or when we talk about an element named as, we consider oxygen. Oxygen having an atomic number eight. So we need to prepare accordingly. This is an atom of an oxygen. Okay, write down O for the oxygen. Then the electrons will be placed accordingly. As I have already told, the first shell have tendency to hold 2 electrons. So this is 1 and 2. Next shell has the 8 electrons to be held. But here total number is 8. Where out of this 2 have been used. Okay? 2 have been used. So remaining 6. You need to place 6. So this is how 6 electrons have been placed. But still, why I am showing you this? Okay. There are 6 electrons present over here. That's the reason this oxygen element always binds with 2 hydrogens. To form both molecule. Because it still have 2 atoms or 2 electrons remaining by which they can bind up. Okay? So after this, the next thing comes. This is how the electron, this is total 8 have been fixed. The next shell, this is the first shell. Second shell. First shell already shows presence of 2 electrons. Whereas second shell shows presence of 6 electrons. And the holding capacity is 8. for second shell. Whereas for first shell, the holding capacity is 2 itself. Okay, so after this, now moving to see how then the hydrogen is actually able. If we see here, atom, let's name it as hydrogen. It's only fulfilling the first shell, hydrogen element. This is for the first shell, where we already know the holding capacity is 2 and there is presence of 1 electron. So now what exactly happens? Again, repeating the same thing, atom is surrounded by negative charge electrons. Negative charge electrons, okay? Negative. So they always have an orbit, because if they don't have an orbit or if they don't have electrons, if the electrons are not being shared, definitely there will be no bond formed between them, okay? Okay, next moving to, first we will prepare how there is formation of H2. What exactly happens? So as some portion of electrons left, then they share the electron. As per the number. As per the number required. Now, the element which donates, see the word donates, the one which gives, the one which is donor, okay? The element which donates the electron becomes positive charge and is known as cation. The element which donates, the one who is a donor is actually bigger thing. Okay, they become positive. So the element which donates the electrons became positive charge and is known as cation. The next thing comes the element which receives. The element which receives the electron from the other element is known as anion and becomes negatively charged. So here you can see that the cation is the one who is donating. The anion is the one who is receiving. The one who is donating the blood is known as donor. The one who is taking the blood is called as acceptor. Why the acceptor? Because he is actually deprived or she is actually deprived of the blood. Same thing happens over here. So this is an formation of donor or receiver is to make the bonds. Makes the bonds between the elements for forming molecules. Formation of donor or receiver. You're highlighting again, donor or receiver is to make the bonds between two different elements so that they can form molecules. It's not compulsory, it's going to be different. The bond can be between different or same elements. Bonds can be formed between either different or same elements so that they are resulting in the formation of molecules, compounds, and then undergoing into the higher level. Now, need to see what are the different types of bonds. The bond which is formed between cation and anion is called as ionic bond. And the best example for an ionic bond comes with the most important element, of life, that is sodium chloride. Sodium chloride, the one which is most important element. Now, how the ionic bond is being created between them? If we see the ionic bond created between them, this is the element. Let's take this as a sodium element. Let's take here as the chlorine element. Now, the atomic number for sodium is 11. Atomic number is 11. Whereas for chlorine, atomic number is 17. So accordingly, you have to make the shell. Now, if we place so 2 electrons in the first shell, next shell there will be presence of 8 electrons. And 2 plus 8 becomes 10. There is only one remaining, so we are putting 1 in the last step. So instead of putting here, we can put it here. Same is applicable. Same is applicable for chloride or chlorine. This is the first shell where we are actually introducing two elements, two electrons, and then moving to the next 1, 2, 3, 4, 8. So second shell where it has its maximum capacity to hold electrons is 8. So 2 plus 8 becomes 10. So out of 17, there are 10 electrons which have been fulfilled. Now there are remaining 7 electrons still. So the 7 electrons will be placed over here, the next step. The maximum capacity of this third shell is also 8. So here 7 electrons, and in sodium there is presence of only 1 electron. So it's very difficult to take something which is more in number. Okay. So taking 7 electrons from chlorine is quite difficult. So it's way better to donate the electron. So the sodium donates the electron towards the chlorine, and then the result of the formation of a bond, which is called as your, it creates an ionic bond between them. And by sharing of the electrons, the 7 is being shared by chlorine towards the sodium, and 1 is shared by the sodium towards the chlorine, so that they can fulfill the third shelf consistency and the maximum holding capacity, that is 8. So they form a molecule called as your sodium chloride, and the sodium will be always having an ionic bond created between sodium and chlorine. At this point, understood? So this is what sodium chloride, how it has been formed. Sodium chloride, the most important substance which is for life. Why are you saying sodium chloride the most important substance? This is the one from biological point of view, the important element or important compound that is required by muscles, brain, heart, blood, etc. So this is how the chemistry for biologists, and the sodium chloride showing an ionic bond combining the two together is being done or performed. Now moving to the next, undergoing into the next type of bond, which is called as your covalent bond. Should I rub this? Okay. Next, moving to the covalent bond. After ionic bond, covalent bond. So covalent bond is what? The bond which is involved in sharing of direct electrons on the ions. And making them neutral so that they are not getting apart. This is the most strongest bond in chemistry. Most strongest bond. So in this case, there are mostly what we see covalent bond is a condition where uh, the scenario becomes slightly different as compared to the ionic bond. Here, the electron becomes polarized. Now, if we talk about that, if we talk about this, what exactly it becomes? So in this, the electrons, they are not quite evenly shared. Not quite evenly shared, which means they are not shared equally. Okay, so if we talk about this is different thing, different scenario. Now, we can go with the best example for n hydrogen. For n hydrogen atom. So they become more stable. Okay. So if this is the atom, hydrogen, and here is the next hydrogen. Both the element. This is the first outermost shell showing presence of one electrons at each. They will combine together, and this will result in the formation of hydrogen molecule, where we already know this is forming the covalent bond, the strongest bond. So this was about the bond involving sharing of the direct electrons and making them neutral. Okay, even if on neutralization, they are not in a condition where they are like completely either positive or negative. They cannot be positive. Covalent bond cannot be positive. As they are more slightly towards the negative charge and they do not quite evenly share the electrons. But once they are being formed, they are the most stabilized condition. In this most stabilized condition, the molecular formation is easy. So, in chemistry for biologists, that too in subtopic for chemistry of life or chemistry for life, we have studied regarding why water is supposed to be considered as the elixir of life. Next, what are the different organic and inorganic components? What organic components contain the different elements? And then we have seen the two different types of bonds, that is ionic and covalent. So for the next session, maybe we will continue with the coordinating one. Have you understood all the topics? Hamdan, am I audible to you? Okay. You came in middle of the session, so have you understood the concept? You can speak out, no problem. Okay. If you feel like to ask the question, you can ask right now. Okay. Very good then. Fine. So we'll meet in the next session. Okay? We'll see each other in the next session. Fine, no problem. You can come for the next session, and then if you might be having anything, you can ask me there too. Okay then, bye-bye. Take care.